Welcome back. Today we are busy with the ear, and I hope you returned with your break and you're feeling refreshed and ready to go. Right, so we've done the structure of the ear, we've done hearing, and now we're going to look at balance. This is a very important slide in life sciences. If you know this slide, you will be able to answer any question they ask you on balance. Right, there are two ways in which the inner ear will regulate balance. The first type of balance regulation is change in direction and speed. So what do we mean by that? Direction is you walk and then you turn left, right? So you don't fall on your face. Your ear will keep your balance, right? Speed is you're speeding up or you're walking slower, right? So those two stimuli is then causing the crista, which is the receptor cells, which are now located within the ampulla, and remember the ampulla are in the semicircular canals, to now convert that stimuli into a nervous impulse. So what I try to do is make a little mnemonic for you here, and we call it acids, right? Acids. So A is for ampulla, C is for crista. The little I there, I don't have a word for that, but ACDS doesn't make sense, so I just put the little I there to make sense. The D is for direction, and speed is the S. Acids, acids. So if you remember, direction and speed will stimulate the crista in the ampulla. Right, so that's little arrows, that ugly little things there are arrows. All right, so the second way in which balance is regulated in your ear is the position of the head. So the position of the head towards gravity is looking down and looking up. If your ear didn't regulate that, you would look down and fall on your nose. You don't want that, okay? So what happens here is the macula, which is situated in the utriculus and the succulus, will now convert that stimuli into a nerve impulse, right? And the mnemonic I have here is S sump. S for succulus, U for utriculus, M for macula, and P for position of your head. So if you can remember acids and sump, you're already halfway there. Right, now we're getting to a very important part. And this is a very important part in the whole of human nervous system. And that is receptors convert stimuli into impulse. That is one mark. People, we've done this with the reflex arc, we've done it in the eye, we've just done it in hearing, and now we're doing it in balance. If you know this little sentence, you are guaranteed one mark in any human nervous system. Okay, not anyone, but if they ask one of these concepts. Okay, so know this word. Receptor converts the stimulus into an impulse. One mark there. For free, so do it. Send it via the auditory nerve. That is another mark there. And remember, we're busy with the ear. So that will not be the optical nerve, it will be the auditory nerve, right? That's another mark. And now comes the change that's different from hearing, and that's the cerebellum. If you remembered when we were looking at the brain, I showed you the cerebellum. And the cerebellum maintains the balance in the body. Now it's very easy to remember. Ballum sounds like balance. Ballum, balance. Right, so you can see there. Balance. So this impulse will go to the cerebellum. There you will get a mark. You cannot say brain because the examiners are now testing. Do you know which part of the brain this is going to? Is it going to the cerebrum or is it going to the cerebellum? Remember, cerebrum is the hearing or the seeing part. Cerebellum is the balance part. And you have to study this and remember this because they're going to try and catch you out. Right. Now, the cerebellum doesn't just take the message and that's the end of all. You know, now it's good times. No, because if it just ignores it, you will fall on your face. No. It sends this impulse to the affected muscles to maintain balance. So now you look down, and now the cerebellum is now telling your muscles, maintain the balance, or else you'll fall on your face. You don't want that. All right. So this part here at the bottom will be applicable to both of these. You will start off this sequence, or you'll start off this sequence, but you'll end here, right, with the for 3 marks if you know that. But let's just look at a little bit more detail. Right, now we have here a little man, his head is upright and then his head is tilted forward. Now that always immediately tells you this is sump, right? Succulus, utriculus, macula, and the position of the head. So the macula is within the utriculus and succulus, and just by the way, can you see where the succulus and utriculus is there? It's between the semicircular canals and the cochlea. Right, so they don't draw it so nicely as in the other drawing I showed you. Okay, so what happens is basically the macula has got this little hair cells here. You don't have to know the detail or know the names anymore. That's the olden days. And when you tilt your head like that, that jelly layer there will start to sliding downwards, and that will bend the hair cells. And the moment those hair cells are bent, it will be stimulated. And when it's stimulated, you will get an impulse. Remember that magic word, converted into an impulse. Right. And then this impulse will travel via the auditory canal to the cerebellum. Now we get to this situation where you can see this guy is now, he's now turning around. I'm not going to do it, I will fall over. But anyhow, we all did it when we were very small. Just draw, you will go in the circles and then you will get drunk and fall down. Now you do it in different ways, I know. But anyhow, remember when you do that, it is acids. Right. And acids, it's the ampulla and the crista, ampulla, direction and speed. So let's just look at a little bit more detail. Within this little circular canal, semicircular canal, there's ampulla. And in this ampulla, the crista looks like this. This is a whole crista, right? We don't have to know that thing's name. But when you start moving, the liquid will move and it will bend that little structure. And that will cause this hair cells to be stimulated. The crista will be stimulated. It will convert that stimuli into an impulse. Yo, this is so easy. Right. And then it will be sent to the cerebellum. So it's very easy. Can you see acids and sump? Right, I've already said it, but I just want to emphasize. It converts the stimuli into a nerve impulse. That's 1 mark. And it's sent to the cerebellum, 1 mark. Via the auditory nerve, 1 mark. Easy peasy. Now let's look at some questions. Right, now if you look at this structure here, it looks like a little snail. And that little snail is called the inner ear. Right, name the receptors that are found in part B. So firstly, read your question. They are not asking you what is part B, they're asking you the receptors within it. So this is the semicircular canals. They look like semicircles. And the receptors found in them are the crista. Right. And when it's got an E at the back, it's plural. When it's just the crista like that, it's 1. Right, so that's the difference between spelling. Just for interest's sake, some English there. Right, describe the role of part B in maintaining balance. So B is the semicircular canals. So what are we looking at here? Acids. Right, acids. So the crista in the semicircular canals are stimulated by change in speed and direction. So there's our little rhyme there. And here's our for free mark again. Convert the stimuli into a nerve impulse. The nerve impulse are transported to via the auditory nerve to the cerebellum. Can you see that? You can always say these and you will get your marks. Right. Let's look at the next question. Describe how the succulus and utriculus in the human ear maintains balance in the human body. So that is the succulus and the utriculus, right? So that immediately tells me sump, right? So now we have to talk about the position of the head and the macula and maintaining of the balance. So there's my macula mark. And it's found in the utriculus and succulus. Can you see you're not getting a mark here? Why? Because it's in the question. They're not going to give you for 3 marks if they give it to you in the question. Remember that. So yes, you can mention it, but you're not going to get a mark. They are stimulated by the change in the position of the head. That's where the P comes in, right? And then the stimuli are, here's our sentence again, people. Stimulate are converted to a nerve impulse. This is like just, you can wake you up in the middle of the night and I can ask you this and you must be able to say this to me. And then it's transmitted via the auditory nerve, who knew? To the cerebellum, who knew? So you see, the same 3 marks again. And now, this part addresses, you see it's 5 marks. It addresses what happens after the cerebellum. It sends the impulse to the muscles, which enables the person to maintain balance and body position. So that the muscles can now react and you don't fall on your face. Well, I think you are tired, I'm tired, so let's get to an ad break, get some tea or coffee going, and I'll see you after the ad break.